So now that we've done the not so great tool of JuiceFS, we can talk about the much greater tool of boto3. So boto3 is a Python library, I think maintained by AWS, like Amazon. And so it is open source, but Amazon maintains it. And it basically provides like a Python API for all of the things that S3 and S5 let you do, just like making buckets, downloading files, but then also has a lot of other tools to just do stuff faster. So it has options. The main thing I'm going to talk about is you can open an object from a bucket, and then you can just like stream in X amount of bytes at a time or X lines at a time, and then just do all the processing you need on that while the next one's getting ready to come down. And then so that removes like a lot of the latency and lowers the memory usage a lot because you only have small amounts of bytes in at a time. And it also provides a lot of other stuff. Like I didn't have this in my notes, but after your question, I did look up, and it seems like, at least the way I found really quickly to do what you wanted, is you can specify a range of the file when you first open it through Boto, and then you can do the same streaming thing, and you can just stream over that range of bytes that you wanted to process instead of downloading a really big file, which I'll get more into that when I actually talk about all the commands you want. So first, to set it up, it's actually installed by default in the Python Docker image. So you just do like apptainer pull docker //Python. It's set up in, I don't remember what folder she told me it's in anymore, but it's set up, it's already downloaded here somewhere. So you guys don't have to pull it. It's probably in apptainer. I think it's here. Yep. So if you guys want to just copy this to your home directories, it's /sw/containers/Python, and then the Python latest. It's the only file in there. So that is the apptainer container with Python and boto3 already installed in it. And so that's really all you need to do for the setup. I would also recommend setting up the environmental variables I've been using. So that's detailed in the S5 command setup. And so that just makes it so you don't have to hard code your keys into everything when you do it. You can just load that variable into your script. But I mean, for now, you can just hard code them if you want to follow along. And then, so the things you can do with this is it can do the basic download and upload files. This will also all be on the docs when we get those up, but it's just like s3.download file, and then you give it the bucket name and object that you want to download, and then upload file is s3.upload files. And you can create and destroy buckets same way you did with S3, just with the, like, I think just make bucket, create _ bucket. And then more interestingly, you can change like bucket policies, like who can access it. So you can basically set up and configure a bucket specifically for this job, and each job can do it slightly different based on how you configure it. And but then the biggest thing is you can, I guess I'll open this up. So with this command here, .iter chunks, you can set up, first you set up your client, which is how you basically connect to Kopah. So you tell it, this is S3 protocol, and then it just loads the endpoint, which is the Kopah whatever, and then your access keys. And so these are all loaded through the OS module, which is just os. And these are all your environmental variables. So that will set up the client connected to Kopah. And then you can get a specific object from a bucket. So this would be a bucket that already exists versus JuiceFS made it for you. So this would be more for like your input data. And then you can also in that same script create a bucket for your output data and all that. And so it would be just bucket name, and then object name is like if you had an object in a files directory called test, it would just be files/test. It's what shows up in the bucket. And then you have to get, this is called like the streaming body is just the object. I don't know why it only does body there. So this gets basically just a little object that's defined in boto3 to let you stream the data instead of having to download the whole file and then step through it. So you get the streaming body, and then you can just do a simple for loop through the data. And so this sets it to do it 1024 bytes at a time, 1 kilobyte. And then you can do any processing you want in here. I'm just printing it for now. And then you just have to close the data afterwards. And so this iter chunks, you can change the chunk size to be however you want. And then you can also replace this with iter underscore lines. And so that'll just, it's the same underlying thing, but it'll cut it off at new lines instead of just random spots in the bytes. So I don't really remember how CSVs are formatted, but I'm pretty sure that would be a helpful thing for those. And so this is really great for sequential reads or just like accessing a specific spot and then sequentially reading it. It's not as great for like random access, or if you had like, if an index basically was your file, because you'd have to be like jumping around it. So in that case, you'd still probably want to be downloading the whole thing. But it can, and that's where you kind of have to look into more tools. I only had so long to look into this because there's a lot of tools for this and they're very complicated. And so this is the best use I've found because it brings memory and latency use way down, and it gives you, like, depending on how much processing you're doing, you're going to be bottlenecked more by the processing speed than the data speed. So you can get pretty much the same performance you get with G-Scratch with barely any issues except just having to write it slightly differently. And then, so this part here, it's just boilerplate that has to go into everything because it creates the Kopah connection. And then the documentation is a little confusing. So all those other uses will be on the docs. And so this is just, you get the specific type of, like, depending on what operation you're trying to do. I think they have stuff designed for more random accesses, and that would be you do a different thing here to get to that. But I don't know how to do that yet.
To talk about both use case, first would be we have big multidimensional files, one per day, at output from some.
And so is that like an array?
So like, yeah, an NCDF file, day1.netcdf, or day1.nc, day2.nc. And now we want to generate a time series from 1,000 of those files from day 1 through day 1,000, like a single location in that 3D or however many.
And so would that data all be at the same spot in the file?
Yeah.
Okay.
Just across 1,000 different files, which together make up a terabyte.
Yeah, that would actually, I think, be a perfect use case for this, because you would just do 2 for loops, one for each day, and then one to actually iterate through the file. So you'd just be, so this is where that, like, specifying the range that I was talking about, I didn't get to look too far into that because I literally just had to look at that while the other presentation was going. But it seems like when you basically write around this step, you can say, I just want to look at this range of data, and you'd give it the start byte of that section of data and the end byte, and then you can just iterate through it and process it the way you want. I think you can also read the whole thing at a time if you don't want to do it the iteration. So if it's fairly small per day, it would work pretty well. But I think that would work really well, and I'll make sure to add is that probably a common use case? I'll make sure to add that to the docs when we get to them. So yeah, did you have one?
I was just curious, like, in this sort of chunking when I've tried to go down this route before, it seems like there was a pretty hefty amount of pre-processing that was necessary in order to chunk the netcdf files in a way that you could do a one-to-one correspondence of what the dimensions are to find that address of where you take in the file. Oh, I was stored each coils. You know.
Okay. So I'll be honest, when I was writing this, I was looking at a different tool for like 90% of the time, and then I eventually figured out it's just much more complicated than we really need, and it kind of requires a lot more infrastructure. So I kind of like only really looked into this for like a week. It seems very useful. I did do a decent amount of testing with it, and like I did a little bit of performance testing and stuff too. It's about what was it, a fifth as fast as G-Scratch. And so what is the processing? Like, based on your file structure, you need the pre-processing, or the tools seem to do a lot?
Well, generally, when you're doing a read from netcdf, you use specific calls from the netcdf directory to say read the hyperslab along this dimension from index along this index. You can't do that directly to an S3 bucket because the data has been turned into an object, so you don't have the necessary dimensional input.
So is this like you need a header to get all the information?
Yes.
Okay. So I think that would be you just lead it off with a section read, so you can get all that data into. I think the way you can do it is you can just like open a file and then download that section of the object into that file, or even just like into an object.
I guess the question that.
Yeah, so it's there's the download files command, and there's also like download file object. So literally just instead of giving it a file path name, you give it like you would do like the with open f as file, or with I don't use Python very much, but there's like a with, I think, command that you can, I guess it's a keyword, but you can just open the file the standard way that you do in Python, and then you pass that as the argument, and it'll download whatever data was in that object you told it to download. And so this is like, I'll make sure to be adding all of this to the documentation, and it's honestly, the boto3 docs aren't great, so it's been a bit of a struggle to figure all this stuff out. Like I figured out that one command from Googling during that other talk, but this seems like a really good use case for it. And it's kind of just the fine details of which commands to use, but I'm very confident I can find the ones and get them up there somewhere.
What sort of files are you generally?
I just did this with this is a test file.txt. So I haven't done like super extensive performance testing. I have actually a work in progress scripts like that I'm working on right now to get all of this actually fully tested. But it's just, to be honest, I ran a 10K this weekend, so I was a bit busy. I tried to get like just get an idea out there of what you can do with this, and then just where to start looking for the kinds of like what kind of workloads you would want to use this for.
So it sounds like if you actually typically manipulate files in this way.
Yeah, so if you need like random accesses, essentially, I mean, random as in you go somewhere, it tells you where to go, and then you go there. It's possibly with that, what I was saying about like, you can specify a range of data that might work, and that would probably be worth setting up. But this is kind of a thing where you aren't going to really change your workloads to be doing this. Just for any future things, this seems like a very good way to do it. Definitely a much faster way. So kind of depending on the like complexity of your workflow, this is where you'd kind of have to be choosing between JuiceFS and boto3. But it's from what I could gather, seems like it will work pretty well for anything where you just need like small parts of a large file. But I guess it'll kind of depend like what percentage of the file you end up processing. If you do like a majority of the file, you probably just want to download it with it like normal. But if you have a massive file that you use like a couple percentage points out, that's where you'd want to get all this working so it's significantly faster. I'm going to convert this and the JuiceFS presentation into an actual documentation slide probably in the next week or two. And then also these notes and these examples will be sent out with that email Kristen was talking about.